Hello everybody, and welcome back to another episode of Beau Maths. Hope you're all having a fabulous day, and we're gonna do some practice today. Last video, we discussed how to add and subtract fractions, and we saw that the key for that was to make what was called a common denominator, so that essentially we were splitting the fractions up into the same size of piece so that we were able to add and subtract them properly. So we're going to get some practice with doing that, and by the end of this, you should be feeling a bit more confident. So you've got to try these yourself first, you know the drill, and then once you've done that, we're going to get into it. Alright, so we have calculate the following, and then it's just a few different addition and subtraction problems. So we'll start with part A. It says 1/3 plus 2/9. Alright, so we need a common denominator between 3 and 9, right? We're doing 1/3 plus 2/9. So what will be a common denominator between these two? Well, we essentially need to find the lowest common multiple of these, but since 3 is a factor of 9, that means that 9 is going to be a multiple of 3. So all we have to do is multiply the numerator and denominator of this first fraction here by 3, because that's going to get us to our common denominator of 9, right? So 1/3 becomes 3/9, right? They're equivalent fractions, and we're adding it to 2/9. So now that we have the same denominator, it's as simple as adding the numerators out of the same denominator, right? We're saying we have 3 pieces of size 1/9 and 2 pieces of size 1/9, so in total we have 5 of them. So that's part A done. Alright, let's do part B. We have 5/12 plus 1/16. So for this one, it's not as simple with the common denominator because, well, neither are multiples or a factor of the other. But what we can do is we can find a common multiple, the lowest common multiple of 12 and 16. And that will be what our common denominator is going to be. So we can split 12 up. So to do this, we need to find their prime factorizations. So 12 is 2 times 2 times 3. And 16 is 2 times 2 times 2 times 2. Alright, so the lowest common multiple, that's going to be what covers both their prime factorizations. So we need 4 2's, there's no way around that, because that's going to cover 16. But then the 2's are covered for 12, so we just need the extra 3. So in total, that's going to be, well, these 4 2's are 16 times the 3 is 48. So our lowest common multiple is going to be 48. So that's what we need to use for our common denominator. So for this first one here, to get 12 to be 48, we need to multiply it by 4, right? Since 12 times 4 is 48. And so we have to do that to the numerator as well. And so doing that, we have 5 times 4 is 20, and 12 times 4 is 48, so we get 20 over 48. And then the next piece is this 16 needs to become a 48, so let's multiply the numerator and denominator by 3 each. Since 16 times 3 is 48, so we get 3 on the top and 48 in the bottom. So now we have the same denominator, it's just a matter of adding these two. So 20 plus 3 is 23, so we get 23 out of 48. And that can't be simplified, so that is our answer for part B. Let's go on to C. So we have 4/11 minus 2 out of 7. Alright, so once again we need a common denominator. So we have to look at the lowest common multiple of 11 and 7. But 11 and 7 are both prime numbers, so they're automatically co-prime to each other, which means their lowest common multiple is just going to be their product. So there's no getting around it. Their lowest common multiple is going to be 77. So we have to multiply the first fraction by 7 on the numerator and denominator, because 11 times 7 will give us the 77 we're looking for. And the second fraction we have to multiply by 11 on the numerator and denominator to get that 77. Alright, so for the first one, 4 times 7 is 28 over 77. And then for the second one, we have 2 times 11, which is 22, once again over 77. So these are just the equivalent fractions of what we started with, so that's why they're equal to each other. And then we do 28 minus 22 is 6, so we get 6 over 77. And this can't be simplified any further, so that is your answer. Alright, and let's look at part D. We have 5/6 minus 3/7. Well, once again, the lowest common multiple is just going to be the product of these two because 6 and 7 are co-prime with each other. If you recall, two consecutive numbers are always co-prime, so we don't even have to worry about the prime factorization. We can just immediately go and say their lowest common multiple is going to be their product since they are co-prime. So that means for the first fraction, 5 times 6, we're going to have to multiply the numerator and denominator by 7 in order to make it our common denominator of 42. And for our second one, we're going to have to multiply the numerator and denominator by 6. Alright, so doing that, we get 5 times 7 is 35, 6 times 7 is 42, and then 3 times 6 is 18, and 7 times 6 is 42. So now we're looking at 35 minus 18, which is going to be 17 over 42, which once again is simplified. So that is the answer to part D. And if you want more practice, just make up fractions and either add or subtract them. It's as simple as that. And then you can check to see if you're correct by using a calculator. And yeah, so let's move on to question 2. Alright, so it says calculate the following. So it's similar to 1, except instead of just combining 2 fractions, we're combining 3 fractions, or 4 in this case of part C. So just a little bit more work, but overall the same kind of process. So we have 1/4 minus 5/7 plus 4/5. So if you recall, we can actually find the lowest common multiple of more than 2 things, and it's through the same process. So if we look at lowest common multiple of 4, 7, and 5, well, 4's prime factorization is 2 times 2, 5 is prime, and 7 is prime. So since there's nothing in common, these are all co-prime with each other, that means our lowest common multiple is just going to be the product of these three, 4 times 7 times 5. Which will be 4 times 5 is 20, times 7 is 140. So 140 is our common denominator. So to get 4 to 140, well, notice we had 4 times 7 times 5 gives us 140. 7 times 5 is 35, so that means we need to multiply the first fraction as numerator and denominator by 35. 4 times 35 will be 140. Next up, to get 7 to 140, well, 7 times this 4 and 5 give us 140, so the 4 and 5 are 20, so 7 times 20 is 140, so that is going to be what we need to multiply the numerator and denominator of our next fraction by. And then for our last fraction here, we have a 5, so this 5 is multiplying this 4 and 7, which is 28, so that's what we're going to need to multiply the numerator and denominator of our last fraction by. Alright, so doing that, the first one we have 1 times 35, which is 35 over 140. And then we have 5 times 20, which is 100 over 140. And then we have plus 4 times 28, which might not be one you know how to do in your head, so we can do it on the side here. 4 times 8 is 32. 4 times 2 is 8, plus the 3 is 11, so we get 112 over 140. So these are all of our equivalent fractions. Now, one thing that I didn't show you explicitly in the lecture video that you can do with these is, because we're just looking at the numerators now that we have a common denominator, we can put them all into one fraction. So we have the 140 on the bottom, and then we just rewrite all the numerators kind of in on the top here. So we have 35 minus 100 plus 112. So now we can just do all of this, and then we're going to get our fraction out of 140. So 35 minus 100 plus 112. Let's maybe do this minus 100 and 112 first. Minus 100 plus 112 is going to be just positive 12. And then plus 35 is going to be 47. So we get 47 out of 140. So we're looking at 3/10 plus 3/5 minus a half. So we want to look at the lowest common multiple of 10, 5, and 2. But the thing is, 5 and 2 are factors of 10, right? So the lowest common multiple will just be 10, right? Because if we take multiples of 5, we'll get to 10. If we take multiples of 2, we'll get to 10. So it's as simple as that. So for the 3/5, we need to multiply the numerator and denominator by 2, since 5 times 2 is going to be 10. And for the 1/2, we have to multiply them by 5 each, right? Because 2 times 5 is going to be 10. So now what we're going to get is 3/10, that's unchanged, plus 3 times 2 is 6/10, and then minus 1 times 5 is 5, and all of that is out of 10. So then we can put them into one fraction, so we have 3 plus 6 minus 5 over 10. 3 plus 6 is 9, minus 5 is 4, so we get 4/10 or 2/5, because that can be simplified, right? Both 4 and 10 are divisible by 2. So 2/5 will be our answer to B. All right, and let's look at the last part of question 2. We have 89/90 minus 5/9 minus 4/15 plus 1/6. All right, so this looks like a pretty big fraction, but on the bright side, all of these you might notice are factors of 90. So that means, once again, our lowest common multiple, or our common denominator, right, is going to be 90. So 9 times 10 is 90, so we can multiply the numerator and denominator here by 10. 15 to get to 90, well, 15 times 2 is 30, and there's 3 30s in 90, so that means 15 times 6 will give us 90. I'll do that in pink here. So 15 times 6 is 90, so we have to multiply the numerator and denominator by 90. So if 15 times 6 is 90, that means 6 times 15 is going to be 90. So we're going to multiply the numerator and denominator of this one by 15. So what does that leave us? Well, we get 89/90, and then we're going to have minus 50/90, right? Because we're multiplying these both by 10. And then we're multiplying this 4/15 by 6. So 4 times 6 is 24/90. And then we're going to be adding 15/90, right? 1 times 15 is 15. So now putting them all into one fraction, we have 89 minus 50 minus 24 plus 15 over 90. So then if you work that out, 89 minus 50 is 39 minus 24 plus 15. So let's write that. We can do this in multiple steps, nothing forcing us to do this all at once. And then 39 minus 24 is 15. So we get 15 plus 15. And 15 plus 15 is 30. So we have 30 out of 90. But this can be simplified. And it can be simplified by quite a lot, actually, because 30, that's a factor of 90, right? So that means the greatest common factor of 30 and 90 is going to be 30. So we can just divide both of these by 30. 30 divided by 30 is 1, 90 divided by 30 is 3. So this whole mess here simplified down to 1/3, right? So that equals 1/3. All right, and for extra practice, again, just make up your own fractions and add them and subtract them, but this time try and do it with more than 2 fractions, right? These were with 3 and 4 fractions. You could get crazy, do like 10, 11, however many fractions you want. So question 3 says calculate the following by converting first to decimals and then converting back to fractions. So we have 1/8 plus 1/5. So we know how to do this with common denominators, but at the very start of the last video, I mentioned a different possible way of going about it, which, although it's less efficient, it is still a way that you can calculate this, and it's good to know. So the idea is we convert these into decimals first, then we add up the decimals, and then we take our decimal and we convert it back into a fraction. So this can also give us some practice with converting between decimals and fractions, which we talked about how to do in some previous videos. So let's start with converting 1/8 and 1/5. So to convert 1/8 to a fraction, that's the same as 1 divided by 8, right? So we go ahead and do our long division. So 1/8 is the same as 0.125. So that's going to be our first decimal. Now we want to look at the 1/5. All right, so we're doing, 1/5, again, that's the same as 1 divided by 5. So we're doing 1 and we're dividing it by 5. So now our question is no longer 1/8 plus 1/5, but it's rather the equivalent decimals of 0.125 plus 0.2. Now adding decimals, you just make sure that everything is nice and lined up at the decimal. So this 5 comes down, this 2 comes down, 1 plus 2 is 3, have our decimal, and 0 plus 0 is 0. So this is 0.325. So now we want to convert that back into a fraction. So what we did is we took the number without the decimal and we put it in the numerator of a fraction. And so since there's no decimal, that means there's technically a decimal after the 5. So now we consider how many decimals it was moved over by. It was moved over 1, 2, 3. So that is how many zeros we need for our power of 10 in the denominator to convert this into a fraction. And if any of this isn't looking familiar to you, please go back and watch the videos on converting fractions to decimals and decimals to fractions. But yeah, now we're at this point here. So now it's just a matter of simplifying this. So we can find the greatest common factor of 325 and 1,000 in order to simplify this optimally. So we'll prime factorize them. 1,000, that's going to be 2 times 2 times 2 times 5 times 5 times 5. And 325, this should factor into 5 times 5 times 13. So for the greatest common factor, it's just all the commonalities. So that's just going to be these two 5s here. So we can divide these both out by 25. Right? 5 times 5 is 25. So dividing the numerator and denominator by 25 each, that'll be the most simplified fraction when we're done. 325 divided by 25, you'll find is 13. And 1,000 divided by 25, you're going to find is 40. So we get that 13 out of 40 is the answer to this problem. And if you want, you can also try and add these up with a common denominator, and you're going to see you get the same thing. Of course, it would have been with a lot less work. However, once again, the point was to just show that we can do this in multiple ways, and it's consistent. So for extra practice, if you want, make up your own addition and subtraction problems, and then use this method of converting to decimals, adding them, and then converting it back, and get some practice that way. All right, so let's move on to question 4. All right, it says, calculate the following, and we can express our answer as either a fraction or a decimal. So in question 4, we see that we actually have a bit of a combination, right? There are fractions and there are decimals being combined. We know that we can convert between them, so in order to actually add and subtract these, we're going to basically need to choose whether or not to convert the fraction into a decimal or the decimals into fractions. And you can do it both ways and you should get the exact same answer. So we'll have a little bit of variation with this. But for the first one, 1/5 minus 0.11, I'm going to decide to do this by converting decimals into fractions. So this 0.11, we can write that as 11 out of 100, right? All right, so now in order to combine these, we just need a common denominator. 5 is a factor of 100, so we can multiply the numerator and denominator by 20. And so we are going to get that 1/5 is the same as 20 out of 100. So there's our common denominator, and we're subtracting off 11 out of 100. So that's going to give us 9 out of 100. And it says express your answer as either a fraction or a decimal, so it's good to leave it like this. But if we want to write that as a decimal, well, we can write that as 0.09 because we're taking this decimal and we're sliding it over by 2 places when we divide by 100. So either of these will be our answer to that one. All right, let's go on to part B here. So we have 0.482 plus 3 out of 10. So for this one, I think I'm going to convert this 3/10 into a decimal because that looks like it's going to be easier to convert than converting 0.482 back into a fraction. So converting 3/10 into a decimal, all we have to do, since we're dividing by 10 here technically, is just move this decimal over by 1. So this gives us 0.482 plus 0.3. So this is going to become 0.782. And we can express that as a fraction. And if you're interested, I'll just do that with my calculator here. So 0.782 as a fraction looks like it's going to be 391 out of 500. All right, and let's move on to this last one here. So we have 9/20 minus 0.4, and then adding 0.013. All right, so I think it's going to be easier to convert 9/20 into a decimal this time because otherwise we would have to convert both of these into fractions, so I think that'll be less work. So we want to convert 9/20 into a decimal, so that means we're going to be doing 9 divided by 20. So we get that 9/20 is just 0.45. And then we have minus 0.4 and plus 0.013. Well, 0.45 minus 0.4, that's going to be 0.05, right? This 4 and that 4 basically are going to cancel out, which will leave us with a 0 in this 10th spot. And then we have plus 0.013. So we're going to get 0.05 plus 1 is 6, and this 3 didn't combine with anything because it's in the thousandths place, but there's no thousandths place in this decimal. So we get 0.063 as our final answer here. And if you want that in a fraction, that's just going to be 63 out of 1,000. And for some extra practice, once again, just make up your own problems with a combination of decimals and fractions, and you can try multiple ways of solving it, either by converting everything into decimals and then adding and subtracting, or converting everything into fractions and adding and subtracting. All right, let's move on to the last question. All right, so the last 4 questions have been computation-based questions, but you know me, I like some of my theoretical questions as well. So we have a question here, true or false. Given a sum of 2 fractions, if you use the lowest common multiple to find a common denominator, which is what we've been doing, right? We've been finding common denominators by looking at the lowest common multiple of the denominators. We saw that that was the most efficient way to get a common denominator. Will the resulting fraction already be simplified? So is that true or false? Well, if you do enough of these problems, you're going to know that it's false, because sometimes when you add 2 fractions where they have a common denominator, it's still going to give you something that can already be simplified. So for example, 3/12 plus 5/12, that gives me 8/12. But 8/12 can be simplified, right? 8/12 can be simplified into 2 out of 3 because these are both divisible by 4. So what would give me 3/12 plus 5/12? Well, 3/12 is the same as 1/4, right? Because 1 times 3 is 3 and 4 times 3 is 12, so they're equivalent fractions. So if we looked at 4/12 plus 5/12, so if we started with this, then we would see, okay, the lowest common multiple of 4 and 12, we would find that that's 12, since 12 is a multiple of 4. So then we would convert this 1/4 into 3/12. We would add them together, but we would still be able to simplify it, despite the fact that we technically were able to use the lowest common multiple to get this common denominator here. So we see that that is an example where this is false. So it has to be a false statement. The resulting fraction isn't necessarily going to be simplified, even though the lowest common multiple gives us kind of the optimal route to actually find our common denominator. Alright, so I hope you found that video useful and that you're feeling a little more confident with this concept now. Feel free to leave a comment if you have any questions or any suggestions, and I'd be happy to look at those. Well, I'm looking forward to the next video, so I'm going to see you then. But until then, have a good one, stay groovy, and I'll see you in that next video.